Hey, let's talk about deploying applications to AWS. AWS famously has more than 17 ways to run containers. This happens when you're the biggest and one of the oldest cloud providers. The way AWS fixes this issue usually is by releasing even more services to run containers, probably in the hopes that this new way will become the way, at least for some kind of workloads. Containers, as you know, solve the packaging issue for your application. Once packaged as a container image, you can deploy it anywhere. Ideally, you want to just say, run this container image behind this domain and call it a day. In reality, you always have to take a few more steps. You need a load balancer, you need an autoscaling, you need to connect your containers with the database, and so on. In case of Kubernetes, you need even more than that, with lots of moving pieces, ingress controller, and so on, but let's not talk about Kubernetes anymore today. The easiest, most flexible, and serverless way to run containers on AWS is ECS together with Fargate. It has just a handful of simple concepts, and to expose the application, you only need to provision an ALB and connect it to your ECS service. It's not too complicated, but it's also not ideal. Google Cloud does it a bit better. They have a service called Cloud Run, which just takes a container image, gives you a URL, and that's it. It scales your application automatically by using serverless functions. No load balancer to handle, everything is nice and easy. We are using Cloud Run for our product Claymora. It's a simple, easy-to-use timesheet software that is built for European businesses that need to comply with digital time tracking regulations, and it works great both for independent freelancers and for companies. Enter AWS App Runner, Amazon's answer to Cloud Run. Finally, we don't need to mess around with VPC, with ALB, with anything really. We can just take a container image and run it on AWS and pay only for containers themselves. Or is it really that simple? Let's find out. Recently, we released an open source tool, Voice to GPT. It allows you to talk to OpenAI's GPT and it will talk back to you. It's basically a voice assistant powered by GPT. We already have container images built and publicly available for anyone, thanks to GitHub Actions and GitHub Package Registry. Let's try to deploy it using App Runner. I'm going to do that directly via AWS console, doing a shameful ClickOps. At the end of the video, I will tell you how to do this properly. Applications are called services in App Runner. Let's create a new one. Already on this screen, we see a problem. We can either use container images from AWS ECR, or we can connect our github.com repository. So if you're using any other container registry or any other source code management platform, then you're out of luck. Let me choose the image and the tag. We can enable automatic deployments whenever there is a new image tag, which is nice as long as it's working. We also need to create a new service role so that App Runner is able to access ECR. On the next screen, I will fill in the service name as Voice to GPT with API. And next, we see another App Runner limitation. Our containers can only have a maximum of 4 vCPU and 12 gigs of RAM. This is not a huge deal because that's a limit per container. App Runner scales the number of containers automatically for you, and it's actually good to have many smaller containers than a few huge ones. Next part is environment variables. I need to fill that in with an OpenAI API key so that this app is able to access GPT and Whisper APIs. I have the key in AWS Secrets Manager, so I can just reference an ARN here. Next, I need to change the port to point to port 5000, default Python Flask port. Autoscaling part is probably the most interesting here. We can tell App Runner how many instances at the same time to create, and we can set the concurrency. Instances means a number of containers, each having the number of vCPU and RAM that we specified earlier. Concurrency here means how many concurrent requests can a single container process. So if my Python app can handle at most 5 requests, we would set 5 here. As soon as container reaches this limit, App Runner will create more instances. It's a curious concept because autoscaling in AppRunner is always bound to how your application works and not to CPU or memory consumption. You need to know how your app processes requests in order to be able to configure the autoscaling. Otherwise, you might end up with performance issue, or you will just overpay for the number of instances that AppRunner created for you. In other words, you need to do your homework to be able to configure AppRunner correctly. As for this service, I will just use a default configuration. Next, we need to configure an instance role and IAM role that our instances will use. It's impossible to skip this step, which means you have to know how IAM works. I already created the role in advance and will just pick it from the drop-down list. We could also enable web application firewall for our app, enable tracing with AWS X-Ray, and connect this service to VPC if we have a database running there, for example. I will skip all of those options because I really want to see this application up and running. Finally, I can review my configuration and deploy the app. We can see here an averagely nice interface with logs, metrics, and various metadata. We can see a default domain assigned to the service. We could also use our own domain name, of course. While it's being created, let's check metrics. Here at the bottom, we see a metric for concurrency, which could be really useful to understand how your application is working inside AppRunner and to properly tune autoscaling configuration accordingly. If we wait long enough, we will see the error message telling us that IAM role can't access the secret. That leads us to learning two more issues with AppRunner. First, it did not try to make our lives easier and anyhow hint us that we need to adjust our IAM role to set this policy. So we went through this kind of user-friendly UI and it never gave us any hint that we need to adjust the role. Second, we cannot simply modify the configuration of this service if it failed the initial deployment. We have to delete it and recreate from scratch. Yes. So I guess let's do everything from the beginning. At this step, if we pay attention this time, AppRunner offers us the policy template. It does not have our exact secret filled in, but hey, it's something. I can copy this and adjust it inside the role inline policy. Now let me fill in everything again and deploy one more time. Finally, we can access the application. As a reminder, it's a voice assistant based on GPT. You talk to it and it talks back to you.
Tell me a joke about the dog.
Q. What did the dog say when he sat on sandpaper? A. Rough.
It's only an initial version and we will improve it in the future. Check out our channel for a video from Pablo with more details on how it works, and also listen to the DevOps Accents episode 8 where Pablo and Leo discuss this tool in a bit more details. Now that we have an application up and running with AppRunner, we can make some conclusions about the service. I know that from the video it seems simple. In a couple of minutes we got our application up and running, available over the internet. In reality, I had to spend a ridiculous amount of time to get to this point. I showed you one example. Wrong IAM configuration results in a failed initial deployment, which forces you to recreate everything. And that's not only IAM configuration. If you misconfigure any little thing during this service creation step, you'll have to do everything from scratch. So you could make a typo in the secret name, you could forget to configure VPC correctly, anything, and that will force you to do everything over again. Another issue that I faced is a weird bug in AppRunner. Basically what happened is that I configured the health check correctly to point to the port 5000, and I could see in application logs that the app runner tries to access the application correctly and application responds with the 200 response code. So health check passes, but app runner thinks that it does not pass, and it says that initial deployment failed, and I was stuck. My only option was to just recreate the whole thing. And after I recreated with exactly the same settings, it just worked. And a couple of times it happens that I had to reconfigure everything more than 2 times with exactly the same settings just for app runner to pass this initial health check. Another problem is that app runner does not make anything easier for you. You still need to know how to use VPC, IAM, Secrets Manager, CloudWatch, and all the other tools. You even still need to think about how to properly configure the autoscaling, making it somehow less serverless, I guess. And honestly, it should not be in such state. It's been 2 years since the initial release, and it's still hard to find any significant benefits of App Runner. The only win I found here is that I don't have to set up an ALB and ACM to get my app available on the internet. But in return, I get something of a beta version of GCP's Cloud Run with really frustrating bugs and a price of minimum of $30 a month, more or less the same as an ALB with ECS Fargate Spot setup and way more than a similar AWS Lambda-based infrastructure. So, I mentioned that I will tell you how to do this deployment properly with automation without any ClickOps. Our recommended tool for this is AWS Copilot CLI. It's an open source tool that AWS built to make it as easy as possible to deploy containerized applications on either ECS or App Runner. You can easily use it inside CI/CD, and it automates everything in the proper way using CloudFormation. And at this time, it really has all the features built in that you might ever need probably for your application. We have a video about AWS Copilot that I will link in the description below. That's it for this video. Please tell if you have any questions about App Runner or whether you have some experience running it in production. This service is still new, and I'm really curious how many people actually use it for their workloads. Don't forget to subscribe to our channel and press the like button. Thanks for watching.
There are no challenges that we couldn't overcome. Whether it is immediate infrastructure problems or planning a future project, we won't simply answer your questions. We become a part of your team to help you complete the mission. Our solutions consider the interests of your business and the combined expertise of the industry, as our staff is made up of more than a dozen experts in different areas who share decades of field-tested experience and knowledge with you.